Good afternoon, everyone, and welcome to the Biarri Networks webinar, the future of fibre FTTx deployments. Welcome today. We're joined here from Brisbane, Australia, Paul and I. It's great to have you. So, as a bit of a precursor for those of you who don't know who Biarri is and what we do, Biarri is a leader in the planning and design of fibre optic networks. So Biarri uses sort of the field of operations research, mathematics, machine learning, AI, and customized software to optimize the sort of end-to-end fibre network rollout. So through this approach, our aim is to help everyone from telecommunications companies, engineers, municipalities, and consulting and manufacturers to all benefit from these to all benefit from networks being deployed sooner, faster, cheaper, and giving everyone greater confidence. So just to start us off, my name is Nick Guy. I'm the marketing manager for Biarri Networks, and today I'll be hosting the webinar for us all. I've got with me Paul Sulisz, who's joining us as sort of the core presenter today. Paul's the Global Head of Customer Delivery for Biarri Networks. So he works with our customers across sort of everywhere really, so 5 continents. And it's Paul's goal to support the transition of the telecommunications and engineering industry by educating on the benefits of what I was saying before around optimization, big data, and new technologies. Our guest speaker today is Michael Measels from 3GIS. Michael's role is an enterprise architect. So he focuses on showcasing how through the adoption of simple, smart, fast GIS solutions for fibre network planning, design and construction, again, telecommunications companies, engineers and municipalities all can deliver real bottom line results. So before we start today, I just wanted to go through a few key housekeeping points. You can see on the right-hand side of the screen when we go to webinar panel that you'll be able to grab my attention throughout the webinar by clicking the raise hand button. With that, I'll be able to sort of get in touch with you throughout the webinar if you have any queries or something like that. Also, we're going to be pushing through with the presentation today, and we've got some a question time at the end. So throughout the webinar, if you have any questions, just send them through, and at the end we'll make it our best effort to get in touch with everyone. What are we really here to do today? We're looking to sort of look back over how networks are planned and designed, and sort of reimagine the process in which we can go about deploying networks and move towards a more data-driven, automated and optimized world. So today we'll be going through a few key points such as why we are making this change, what's the sort of key drivers, what does the future hold, who's changing things up, what is a new process, and sort of what are the key success factors or pitfalls. So without further ado, I'll pass this on to Paul Sulisz, who will start the presentation off. Enjoy.
Thanks, Nick. Good morning, good afternoon, depending on where you are in the world, and thanks for joining. So look, we'll get stuck into it. So we thought we might just start off with a really good quote from one of our leading innovators of our time. So never before in history has innovation offered promise of so much to so many in so short time. So just thinking through this, so much, so many in so short a time is quite a powerful statement, and I think it rings true for various reasons. So the reason I think this is so powerful is that never it's been easier really to bring our creativity to bear. We live in a world where there now exists sufficient technology that greatly expands our ability to learn, create, innovate in ways we couldn't possibly imagine 5 to 10 years ago. So what's really stopping us innovating? What's really stopping us being disruptive in our approach? What's stopping the greater community to get on and create, innovate and solve some of the largest complex problems we're faced with over the years? So what I find interesting, that oftentimes we all hear, these stories around pioneers, explorers, great innovators, inventors indeed. Over time, we often start with where these great men or women were born. Where did they come from? Furthermore, we express these origins with certain inflection in our speech that would suggest that these origins are unlikely, that we're surprised that genius was born out of the strangest parts of the world. So if we, the collective community of professionals in the telco industry, have the ability, that is the technology and know-how, coupled with this great opportunity, as Bill Gates puts it, to help connect the world, so why don't we? Don't we have an obligation? Isn't it behoove on us to collectively connect people, connect communities? Because who's to say in 5 years' time we could be instrumental in allowing the next Bill Gates, the next Steve Jobs or Elon Musk to access information that's currently globally dispersed, so as to enable that one, or in fact a community of collective minds that make the significant breakthrough, be in the field of science, technology, medicine. So to us, and to me in particular, I think that's a really cool thought and very powerful. So, isn't it a worthy ideal? So why don't we really pursue that worthy ideal? So we know the world around us appears to be moving faster. We seem to be just constantly having the accelerator on. We as humans have this insatiable appetite for speed. And I mean going fast, not the other kind, obviously. This has got to be one of my favourite graphs. Isn't it fascinating when we look at the speed of adoption, just how much the speed has increased? How as a species we insist on accelerating? Even if we compare what the iPod did for us, and adoption took 4 years, seems like an extraordinary short period of time. Whereas Facebook halved it. Then you look at Angry Birds in just 35 days. And more recently, as my kids continuously remind me, Pokemon Go, 19 days to hit 50 million users, which is quite fascinating and very powerful when you think about the forces in the world that drive that sort of adoption. So this need for speed simply means that we need to find better ways, faster ways to connect, faster ways to build and improve our networks. And it's clear that there's a demand. So how do we fulfill this need? So really there's been a significant shift of expectations. It's been ever present in the discussions we've witnessed and had globally in this, and even earlier this year we heard this echoed amongst this community, that fibre is indeed becoming a utility or an amenity, and it's mandatory. It's no longer a nice to have or a luxury item to have broadband, high-speed broadband in each of our homes. People take connectivity very seriously, particularly wireline or fixed broadband connectivity. I know years ago, just from my experience when I was more involved in wireless networks, people were already frustrated by lack of coverage, and they'd make decisions on where to live based on purely the mobile coverage, because that's all they could get. Furthermore, they were really conscious of where the next evolution of that wireless was happening, whether it be 3G or 4G. So they were really coming to myself and friends of ours that really were also involved in this community, asking where should we go to where we know we'll have good coverage, which is a really fascinating way to look at where you should, uproot and move your home and indeed your family. So now we're seeing these global trends that suggest our communities are just as frustrated with fixed broadband, and we will make decisions on where to live on the basis of whether there's fibre in the area or not. If you're anything like me and with my kids, if my wife and I announce a holiday to our kids, one of the first questions that they ask us is, will there be internet? Will there be Wi-Fi? And they seem extremely puzzled when we say, well, we didn't really check. They just don't understand that. They don't understand why we wouldn't check that before making the booking first. Quite funny, but at the same time it's quite interesting how they already have this, and the young kids globally have this appetite for connectivity, beyond just Pokemon Go, unfortunately. So if we are to get our communities there quicker, we need to change and adjust the way we view the challenges around planning, designing and constructing these networks. We need to find more standardized and systematic ways through the process from plan to construct. So I'm sure there isn't a carrier, a service provider or other type of engineering provider that aren't continuously looking at ways to predict time to revenue, or get it even closer to the mark. Shoot for lower costs, ensure there's continuous improvement and drive efficiency throughout the build process, there's always a significant amount of pressure on confirming what the actual achievable targets are, end-to-end consistency in design and construct, and being able to do so all at scale. So many of us know that doing it at a snail pace is okay, but really our constituents, our communities won't hold that as being a great option for them in the long run. So over the past few years, we've started to see an increase in companies that not only understand this, but are also willing to take the first steps and go down this road of automation and optimization in a serious way. We've found that this is absolutely happening on the world stage, from Europe through Southeast Asia and across the United States of America. In the USA in particular, we find that it's the engineering companies that are now surfacing and are initiating discussions with us. It's apparent that they have a deep desire to better understand how can they take advantage of these innovations. With that in mind, we'd like to take this opportunity to discuss a number of interesting case studies where such companies have started down this journey and embraced this potentially disruptive approach. So we'll kick off here with ONUG Communications, which is a turnkey infrastructure solutions provider founded in late 1999 by Danny Huffman. Now they provide these services to a number of carriers, government and municipality organisations in the US. Great example of an early adopter company that embraced a number of the key benefits. And it didn't take long to start realising these, to not only for them but also to their customers. As it states here, the scale of design increased up to 13,000 living homes in a 5-day period. And more recently, this has climbed well and truly north of 20,000 living units per week delivered. Additionally, the automation optimization approach ensures the designs contain optimal locations for all the assets and associated bill of materials is reduced. So this is derived programmatically, so we know that your shopping list is going to be nice and accurate when going to put the order in. The modular nature of the workflow means that you can start now, inject the automation into specific areas of existing workflows first, then build from there if need be. And that's essentially the approach that ONUG Communications have taken. Integration, therefore, doesn't become such a challenge or an issue. Finally, with this example of ONUG, although I'm confident these figures have improved since we quoted the last, typically saving of 34% in time and 28% cost savings in the construction side of the projects. I'm sure you'd agree, regardless of where you're sitting, these numbers are quite significant. So another great example, this time from a Tier 1 telco. Chorus Comms was formed in March 2008 within Telecom New Zealand. Now, obviously, many of you may know, New Zealand is a small country off one of our coasts here, so we, in many ways, consider them brothers. So in December 2011, it separated from its parent company, and it's now New Zealand's largest telecommunications infrastructure company. So interestingly, a year earlier than that, the New Zealand government launched its ultra-fast broadband initiative known as UFB. So its objective was to connect 75% of the country, which is approximately 1.5 million homes, with fibre by 2019. So if you think about that, they kicked that off in 2010, and they had the objective of being done by 2019. So they gave themselves 9 years to connect 1.5 million homes. And many of us would agree that in those, at that time, that you would consider that achievable. In 2013, with about 575,000 premises remaining, they needed to pivot. They needed to replan their remaining rollout to significantly reduce costs. At the same time, they wanted to ensure that they future-proof the architecture. Now, many of us know that a pivot such as this, and we've seen some of these, for instance, what's happened here with the NBN in Australia, that has a significant impact on rollout momentum. Everything almost comes down to a grinding halt whilst you make the changes necessary internally and externally to ensure you pivot correctly. So Chorus knew that if they were to pivot, regain rollout speed, they needed an algorithmic approach that would give them flexibility in future-proofing the architecture. And also to ensure optimality, that is to drive down the cost as much as possible whilst retaining that aforementioned success factors. Finally, with this automated approach to the planning and designing, their subject matter experts were freed up to think about the strategic challenges they had instead of focusing on what we would consider the dumb stuff. So that's one of the key benefits that they initially didn't intend for, but it was a happy outcome at the end. That these very smart engineers actually had time to think appropriately around some of the challenges they were going to face in the current part of the rollout and moving forward as well. So now, before we go into the next case study, it's important to note that we're of the firm belief that we can collectively get there quicker if we work as a team. You know, this is one of our mantras that we talk a lot about internally within Biarri Networks, but it really extends to the broader community, as I mentioned earlier. So we've personally found like-minded people across the globe that share that vision, and 3GIS is such a company. And we've worked with them for quite a while now, and I'd like to, you know, again introduce Michael again now to go through the next few case studies.
Sure. Thank you, Paul. And I agree wholeheartedly that the key to our success has been primarily the like-mindedness of our two firms to move forward and present our customers with a solution that really essentially follows three very specific themes. One being a historical theme of organic network creation, to a present theme of the ability to scale, and then thirdly, a future theme as far as kind of a repeatable process that can scale in multiple markets. So with that, I'll talk through Allo Communications briefly. Allo Communications is a Tier 2 provider that's been in service since 2003. They approached 3GIS a year and a half ago from a network management perspective, as they had some smaller markets that they were currently providing fiber-to-home services in. They had the necessity to really scale their deployment type significantly by approaching Lincoln, Nebraska, which is approximately 105,000 living units. And that requirement to build as rapidly as possible, especially given the competitive nature of the market. So they engaged with us and Biarri to provide a path forward, essentially, and develop an architecture that was going to be scalable and implementable within the construct of their existing agreements with the city. Allo in Lincoln is somewhat unique in that it's a 100% underground build, leveraging existing utility assets that the city owns in terms of conduit, and the requirement to place additional conduit if spare conduit was going to be utilized. So we worked in concert with the city, with the design engineer that Allo had selected, Allo, the customer, obviously, in Biarri, to develop an architectural plan that can then be developed, and a design engine could be created to essentially provide at-scale designs to Allo and their design engineer to support permitting and construction. So again, the key here is that they're looking for a scalable solution, not only inside of Lincoln, to augment the organic solutions that have been created in the past, but more importantly, that could be repeatable both in terms of future expansion in the city of Lincoln and secondarily in future expansion in other markets. So the city of Decatur is located in northern Alabama, and it's where our company is headquartered. Obviously, since we're on the forefront of many fiber-to-the-home builds across the country, our goal is to essentially provide our city leadership with the information and tools necessary to making an informed decision as to whether or not a fiber-to-the-home build inside the city makes both financial sense and political sense. So with that, we leverage many of the existing assets available to the city in terms of GIS data, electric, water, gas, and created a design on top of that supporting data against a vanilla distributed split architecture. And what that allowed us to do is understand the cost of the network, not necessarily in terms of a per household cost or per mile cost or even a regional cost, but it allowed us to actually materialize that cost against actual elements of the network that would need to be built if the city were interested in pursuing such an opportunity. So with that, we provided city leadership with a cost to build, which ultimately was going to inform the why decision and obviously the how much decision, so that they could market appropriately both to the citizens and externally to potential Tier 1 and Tier 2 carriers that may be interested in supporting such a build. So finally, Huntsville. As many of you know, Huntsville has entered into an agreement with Google Fiber to lease a certain portion of their network for Google Fiber to provide content to the citizenry. A couple key notes as part of that agreement that are specifically impactful as it relates to automation and optimization of the design is that from the time that the lease agreement was signed, the expectation was that the network build would occur within 9 months of that lease agreement. So what that meant was developing an architecture that satisfied the lease obligations. In addition to that, that also satisfied potential multiple tiers against that architecture. Defining the architecture, delivering a design deliverable that could be fielded in terms of constructability, and then finally a final design to support permitting and construction so that the first fiber service area of approximately 25,000 homes could be constructed by mid-2017. So currently, against the 105,000 premises, we've done 25,000 of those premises into a ready for permit and construction design, with the remaining 80,000 to be delivered over the next 2.5 years. Now we'll have all 105,000 premises designed, at least to a first iteration state, i.e. prior to fielding of that design by the end of the year. So again, Huntsville can define the cost of the network moving forward and prioritize their build appropriately. So some of the key tenets to this design are the fact that we had to support multiple tenants and essentially define an architecture that has not yet been deployed across the United States. So working in concert with Biarri, we were able to provide the consulting services required to develop that architecture, understand the costs of the deployment of that architecture, and make some critical business decisions that allowed them to both meet the elements of the lease agreement that they're obligated to, but also meet future expectations as it relates to a multiple tenant type of network. So beyond Huntsville, Allo, and the other case studies that we mentioned, we really have to try to understand, well, what is the new process? And Paul will go into greater detail as to what the traditional process has been and where we're headed with that. But ultimately, how do we apply optimization analytics to do some of the things that we're used to doing, at least organically, through either manual processes or people? So whether you're a telco, an engineer, or a municipality, optimization can provide key benefits to each constituent element. We can also look at traditional costing models as opposed to actual labor and material costs that the designs allow us to create so that we can make a better formed decisions. So finally, the new process in the case studies that we've mentioned, the keys to success are understanding what the construction-ready elements of that process need to look like. Too often, we work with customers who haven't thought through nor understand what defines a constructible product and the output necessary to support that constructability. From the very first day that we engage with a customer, we encourage the participation of the contractor, if there will be one. If it's self-performed, the self-performing entities that are going to provide the construction services, and the designers to get in a room and discuss, number one, what defines constructible, and number two, how do we get there? So as you see here, there's 4 distinct elements that really help us define the output necessary. The method of construction. If it's an underground build, do we plan to open trench it? Do we plan to directional bore it? Is micro-trenching available to us? Who ultimately is going to do the construction? Are we going to have a tier 1 construction manager that's going to sub the work out to multiple subs? If that's the case, do we need to create output that's relevant to each one of the functional subcontractor? What are you going to construct is key. So that's in terms of material, essentially, and being able to roll that material up into logical groupings so that it's easy to identify against an output. And then finally, where to construct. And that's not only in terms of the pathing of the network available to you, but it's also in terms of the fiber service areas that you want to construct and the sequencing of those fiber service areas. We found that efficiencies against the construction timeline can be found if we sequence construction in a geographic way as opposed to the linear model that we've often seen. So finally, all four of those elements really lead up to the output necessary and required. If we can define the output necessary and required by all stakeholders and define that output, it's ultimately becomes our measure of success. So with that, I'll hand it off to Paul, and he can speak to the traditional processes and how we're applying optimization to that.
Thanks, Michael. So, now traditionally the manual approach means that we bake sufficient time within the process to ensure that we try to do the right thing first up where possible. We don't perform rework, since each time we perform something manually, it induces time and cost into our project. So as a result, the process of getting through designing a region at large, that is large in area, can take months if not years. So we start with network strategy, looking at the entire city usually. Then once we've gone through some high-level estimates of feasibility, we're confident enough to shift to planning. And now we try to firm up these initial estimates, and usually there's some risk involved there. In most cases, we now start to break the problem down. By that I mean the overall city size, we break that down into smaller bite-sized chunks that can be sectioned off and sometimes put into separate departments for design and construct, or in other areas we may adapt a subcontracting model whereby either designs are separated out and into separable portions and pushed out to industry and or the actual construction as well. And it allows us to manage the risk, and it also allows us to better ensure that we can try to multitask the program. And in many cases we do that also to ensure that if something goes wrong somewhere, we have a way to make up ground somewhere else. And let's face it, there's only so much a human can handle, so that's why we do this. We induce this human limitation very early on in the end-to-end process before we even get to construction. So in terms of design, we take our time to get it right. We work out detailed estimates and provide designs ready for construction. Most of this is performed manually. And once in the field, the construction vendor takes the plans and bill of materials and builds the network. Eventually, the build asset is handed over to the team or organisation that will manage or run it. So the as-builts are captured and in most cases around the world archived somewhere and eventually reviewed and verified in the fielding or inspections that happen right at the beginning of either the upgrade of the network or a new rollout. And we've seen this time and time again, and we initially thought we were very special that it only happened here in Australia, but it seems to be a trend that happens everywhere. We somehow archive or put our data on the shelf and it's not a living, breathing document. And let's face it, this data ages very fast. So when we think about how we're going to get there a lot faster, it's important that we think about the key tenets of those industries and those elements of our services that ensure speed and scale. So really what that means is we need to really focus on areas that help us drive to a very much a commoditized design approach. So the key tenets of commoditization are really focused around how you codify, how do you automate, standardize, systematize and digitize your data and everything you have to allow you to take it to the next step. So on top of these key traits, we scaffold the data flows, workflows and our network architectures. And as Michael said before, depending on how many tiers there are in the architecture and elements, key elements like that, then this is where these elements are thought of. They are linked very tightly to the principles of this commoditized approach, to these principles of this algorithmic approach that allow us to focus around the standardization and how we automate and codify everything. So then finally on top of this, we have our input data, the iterated designs and the construction packages. So once we think about those key outputs at the top, and in many ways, input data is one of those key question marks for a lot of people we found. If we think about our input data in terms of data flows, the architectures, and the tenants I mentioned earlier down the bottom of this wall, then we see them in a different light. Then we take an alternative approach to getting there, to making this end-to-end process go even faster. So now, obviously Nirvana is a situation where you start this entire process in a digitized and overall data-driven way. Then you keep as much of that information and data digital all the way through to the end of the build. Of course, there are still elements of this workflow that currently must be paper-based. For the most part, construction drawings are delivered on large pieces of paper. CAD is still prevalent across the world. But that's not to say that the base data remains within the systems and we merely output or take a snapshot of that data in time purely for those purposes. And we use other digital means to catch any changes in the field to ensure that we've got the most up-to-date data. So the 5 aspects of this process are key, and in fact, to focus your attention on ensuring that it's an asset-based design, it's geospatial, to reiterate what Michael was saying, you automate as much of the workflow as possible, you utilize the power of maths to optimize the network, and because that gives you that cost saving, and your workflows remain very much data-driven. And we found when customers and people we've worked with around the world bring things together, the more tightly you can bring these together, the better the results will be. So another way to look at this process is to think about the design itself as being the key centerpiece here. So with an algorithmic, automated, digital and optimized approach, we reap the rewards in a few key ways. Firstly, the design becomes a centerpiece, as I said, since it is readily iterated, taking on inputs from various phases where you perform a site inspection, you do some fielding, as Michael said, you may go out and confirm pathing before you commence. You conduct a construction write-out. Before you commence designs to confirm your pathing, as an example, there's an opportunity to infer many things before you even start this whole process. All the way through to the final design and eventually the as-built. So if things remain electronic, digital, then you have an opportunity to have that data set actually almost real time for the next build or deployment. And more importantly, for the network manager. So iterating large areas does not take long at all if you take this sort of approach. It gives you the ability to check your strategic assumptions and verify quantitatively with the bill of materials that can be output at the end of each stage or at the end of each design iteration, just how close or far away you are from your initial strategic decisions, which is very powerful. And this is, again, just reiterating on some of the key success factors that Michael touched on with some of these municipalities. Because we have this ability in this process to iterate, you can be confident that you're rechecking and everything is still making sense and you're still within budget and you know you're going to hit your time frames. So it really allows you to keep that one eye on the constructability whilst maintaining an accurate view of your potential network deployment costs. And I'm sure most would agree that's quite critical and can be very, very powerful. So when we think about these key benefits, from a telco perspective, you have the clear opportunity to get to revenue sooner. Since your overall deployment time reduces, you have a better chance to recognize take-up sooner. Optimization works for you to ensure cheapest cost network. It will work within your constructible bounds and focus on being efficient at the same time. And as we saw with Chorus, algorithmically building your architecture means that you can future-proof your network. So if you need to pivot on the architecture mid-flight, it's not necessarily a full reset or restart, and everything you need to wait months, if not years, to get up to the same level of momentum. So from an engineering service provider perspective or turnkey provider, this approach becomes very scalable once the initial parameters are set and the resulting designs are compliant. There are a few limitations to the size of the area that you may want to design to in one hit. But once you've got that, let's say you focus on an initial area of, say, 500 homes, Then from there, it's very simple to scale to 5,000 or 50,000. It's just a matter of configuring the tool set once, and there's no need to divide and conquer up that work because you are trying to introduce the human element in the loop. Finally, from an engineering perspective, the key tenets or principles allow you speed and scale in your data flow, allow you to remain agile and overall approach, again, if a pivot is needed. From a municipality or PPP view, you can capitalize on the existing asset base of your network and simply digitize this in the front end of the design process. So your telco network makes use of the existing utility paths where it makes sense. Since the design process is so efficient, the costs are naturally lower than standard approaches and thus in reach of PPPs. Therefore, the end user or the community reaps the benefit if not having to pay a premium just because the cost to connect to each channel is so high. And whilst on cost, since the designs are digitally and algorithmically derived, the output bill of quantities and materials is very accurate, giving you the confidence of what it will take to build that network. So let's talk about 10 tips to speed and certainty. What are the things that may be holding you back, and how can we potentially overcome these? So as I mentioned before, shifting the human limitation bias downstream is quite powerful. By that I mean, as in the traditional processes, we break down these areas so then we can get various teams to work on it right from the planning phase to design. This algorithmic approach means that you don't have to break that area down until absolutely necessary, and then really that can be down at the as far down the chain as the construction phase. This is one of the classic comments I get when I travel around is, we have no data. Well, that's fine. It's not a problem because we have ways and means these days to actually identify the data using various tools and techniques we've discovered. So it's fine. No need to freak out just because you don't have the data. We're more than happy as a team to get you there. Furthermore, other organisations usually say, well, our data's terrible. It's pretty ugly, you wouldn't want it anyway. It's fine, we're okay with it. It's about if that's as good as it's going to get, we'll work with what you have and build from there. So automation is here to stay. There's really no need to go back into the dinosaur era with some of this stuff, and there's an opportunity here to embrace the algorithmic approach. We try to limit how often we take things to big teams offshore and other ways to deliver in those instances. Here we automate away as much of the process as possible. So this is probably one of my favourite quotes. The only constant is change, and I know this. I say this to my kids and my wife quite often, but it's so true. And it's if we embrace the fact that things are shifting, changing, then we're going to be in a better place when it comes to working with these potential challenges in deploying our networks. There we go.
Okay, so I'll pick it up from here. So as Paul alluded to, he focused on several tips around kind of the concept of automation and optimization using technology and some of the key issues with that. So the next few tips are really going to be more focused towards kind of the cultural aspects of the people that we've been interacting with as we both sell these type of opportunities and obviously execute them. So change, from a change agent perspective, it's really critical that we identify those people inside the organizations or that we or you are going to deal with in the future, whether that's an engineering firm and understanding the advocate of that change, to the city and the permitting entity who wants to do things better and faster and cheaper, to the tier 1 or tier 2 communication provider that's really looking to expand their network in a real way, but more importantly in a timely way. So understanding who those advocates to support change in terms of culture is really required for at-scale deployments, really in any market and for any type of customer. So oftentimes, and this is a challenge that we found here in North America primarily, is permitting, both in terms of the Tier 2 and their approach to permitting, and accepting the permit requirements and standards that's being given to them by the regulatory agencies, to the regulatory agencies themselves that haven't created a standard by which to really measure the success of those providers that are intending to construct inside the right-of-way or on their poles. So really embracing a standard, whether you're the Tier 1 or Tier 2 telco, or developing and embracing a standard if you're a municipality or regulatory agency, can really help in limiting the resources and time required for successful implementation. Adopting an architecture. So if I were to talk to a Tier 1 or Tier 2 carrier, an architecture may simply be the network topology that you intend to deploy. In terms of our definition, an architecture is not only the topology in which you intend to deploy, but the elements that make up that topology, both from a material and labor perspective, all the way to a process. So understanding what that architecture is, and the key elements and decisions that are made in applying that architecture, systems, equipment, material, and labor, and defining that into a standard really helps inform the optimization engine so that we can get a repeatable result across large markets. So an architecture in our world is not only, it is the definition of our success while it's ultimately the output of, while the output is the measurable criteria. So everybody can help, and oftentimes we see in working with the customers that there are silos of decisions that are made. Oftentimes construction isn't engaged until after we're well into the engineering process in a traditional sense. So the key to success from an optimization standpoint and understanding the standards required for output is understanding what a change in network topology or architecture has on the downstream relative to construction. And being able to communicate this both early in the process and throughout the process so that we can bridge this gap. And finally, as Paul alluded to, having a design deliverable at the end of the as-builting process that can be easily integrated into your enterprise system and allow for the design and or as-built system to inform your OSS and BSS systems, to your scheduling systems, to your outage management system is really key. So the design deliverable past construction, past the AutoCAD drawing, to inform the enterprise and provide measurable benefits both in the short term and the long term as you manage your network.
Thanks, Michael. So look, to conclude, and I know we're running about that time, so really the key here is, and we hope that what you guys have heard is that, that there's an opportunity to start now, regardless of what stage of the process you're in. There's an opportunity to absolutely go fast, to put the accelerator down, and as importantly, you can be certain about the results, because again, the algorithmic approach using this optimization allows you to be very accurate when it comes to your bill of quantities, bill of materials. So a lot of your metrics and your KPIs you can hit with confidence. So the key really for us, and I really speak to everyone here, is if it's not you, if it's not us, then who else would it be? This is another cool quote I found recently. Change will not come if we wait for some other person or some other time. So really, again, I think it's behooved onto us to take the responsibility to make the absolute use of what we have at our disposal today and really help connect the world to make it far more meaningful and solve some of these challenges that we have across the global community.
Awesome. Okay, thanks, Paul and Michael. As might have seen the chat, I've been asking for some questions. If you've got any more, send them through. But we're coming pretty close to the end, so I might be pretty brief with them. But if you do have any further questions, we're always sort of available. Send them through by emailing us, or yeah. So Paul, this is just to you. So what about sort of the manufacturing space? We've talked about sort of the municipalities, we've talked about engineers, we've talked about telcos. How does sort of manufacturers benefit from this?
Great question. So from a manufacturer's perspective, it allows, there's many different key benefits they can realise from this approach. One of the keys is that if manufacturers choose to adopt a way of approaching a vanilla architecture, as Michael alluded to, then they have some confidence in what to expect when it comes to various rollouts globally, and they can foresee exactly what their materials and their processes should look like, so they can ensure that they've got an optimized view of the just-in-time delivery, really. So I think that's one of the key benefits for manufacturers. Secondly, I think it makes it far easier to work with those that are rolling out networks, because you have this predictability and you already have a digitized view of the bill of quantities. So if manufacturers are engaged early on in the process, then there can be a very much an automated way to, in terms of workflow, to work with the manufacturer. So the end-to-end chain work very tightly together, and the manufacturer knows exactly where things are at throughout the process, which again can be very powerful, because there's, in particular when it comes to long lead time materials, we all know this can be an absolute killer when it comes to timeframes. So this approach allows us to estimate with a very high level of accuracy some of those long lead time materials very early on. And let's face it, everyone wins if we get that right early on. So I think that's one of the key benefits.
Cool, thanks Paul. We are running out of time, so what I might do, there are a few questions here, so throughout the, what I might do is get back to you after the webinar and sort of email you one-to-one. So a bit of a sort of last minute shameless plug here. Later on in the year, sort of September 21st and 22nd, both Biarri Networks and 3GIS are going to be attending and exhibiting. So the expo is being held and it's sort of focused specifically on what we're talking about here. It's about bringing a new way of thinking. It's about delivering new solutions to the telecommunications industry and the rollout of fibre networks. So as you can see here, 3GIS is going to be exhibiting, and they will be at booth 849. From what I've heard from sort of Michael and the team there, they've got a new booth that they're sort of bringing out, so you'll be able to head up and see their solutions in action. For the first time though, and this is something we haven't done before, Biarri Networks is going to be exhibiting at the IIT Expo. We're going to be having Paul Sulisz there, Bonnie Boller, who's head of sales, Joe Forbes, who's the Biarri Group founder and also managing director of Biarri Networks, Fabian Kilker, who's the VP of operations for US as well. So it'd be great to organise some meetings. And along with that, we've got three sort of key things we're going to be doing at the event. We've got our team have made, put some time aside, they've put together an experience, a virtual reality experience, so it'd be great to get you down there to see a real Melbourne Australian design when you're standing there in San Antonio. You'll be able to see one of the core technologies that our team's been working on in terms of a global collaboration platform. And also, finally, we are giving away the opportunity to win a city designed up to 20,000 premises for free. So a great opportunity to come down to the booth and win that for you and your team. So just finally, I'd just like to say thanks for joining us today. Don't hesitate to get in touch with sort of myself, Paul or Michael. it would be sort of great to answer any more of your questions, and I'll be sure to get it through to you. Fantastic. Okay. Thanks a lot for joining us. And yeah, thanks.
Thank you.